Welcome back. And now we're going to jump into the last part of section 7.3, which gets into variation. And there's two types of variation we're going to look at. So the first type is called direct, which states if two values x and y vary directly, then as x increases or decreases, y also increases or decreases. So a common analogy for this would be a telephone call. If you have 1 minute and it's 10 cents a minute, and then 2 minutes would be 20 cents. So as the time goes up, the cost goes up. Pretty straightforward. Now, a lot of this in here is talking about terminology that you don't specifically need, but it is important in some examples, in some applications. When we divide this scenario, where we're dividing a price or the cost of the call divided by the length of the call, we're going to get a formula. So basically, anytime you divide this, you're going to get that 10-cent rate. So 10 cents is the constant of variation in this case. Now, technically, there's no units on it, but in general, though, that relationship, that multiplier, if you will, is going to be the constant of variation. We don't really need to know that. The biggest thing we need to know is how do we set up an equation to solve for a missing piece? And it's very, very simple because we can set up a proportion. So it's going to be exactly the same way that we set up our other proportions. So they're going to give you some information that goes together. So that's going to be one side of your proportion. So the G's are just what's given to you. And then on the other side is one of those pieces will be given and the other piece will not. So you have to just make sure you put it in the right spot. So the key takeaway is anytime you see varies directly, think proportion. That's the underlying principle. So let's do a couple. So we have solved the problem. So as y varies directly as x, and y equals 9 when x equals 4, find y when x is 12. So right off the bat, you got that varies directly. So you automatically know you have to set up a proportion. And then the next bit of information they give you goes together. So y is 9 when x is 4. So if we wanted to set up a proportion, we can just put 9 over 4. And then on the other side, it says find y when x is 12. So where should the y go? Where should the 12 go? And again, it's based on how you set up the left-hand side. So y was on top, x is on the bottom, so you're going to do the same thing. Y is on top, x is on the bottom, which was 12. Now you have your proportion, and now you're on your home stretch. So let's cross multiply 4y, and then 9 times 12, which is 108. And then we can divide by 4. And so y better equal 27. So not anything too drastic, but just be careful with the setup. The setup is always going to be the key piece of it. If you're not setting it up correctly, then even if you got the right style of work or process for work, it's not going to give you the right answer. So be really careful. Okay, so if P varies directly as Q and P equals 90 when Q equals 20, find P when Q is 6. All right, so same thing, varies directly, means proportion. So let's put those two over each other. So 90 over 20, and then P was first, Q was second, so P is on top and Q is on the bottom. So we don't know P, but Q is 6. Now the one other thing we should do as just a quick little check is just make sure that it's going the right direction. And what do I mean by that? Well, remember, if it varies directly as one thing goes up, the other thing goes up. If one thing goes down, the other thing goes down. So look at what happened with the first one. We had x was 4, and then it went up to x is 12. So x got bigger. So that means that y has to do the same thing. Y has to get bigger, and it did. It was 9 initially, and it went up to 27. What about here? What do we expect is going to happen to P? So Q was 20, but it goes down to 6. So if Q is going down, then that must mean P's got to go down too. So that's what we expect in the back of our minds. Let's double check and see. So we got 20P equals 90 times 6, better be 540. Let's divide by 20. And so P is equal to, well, son of a gun, 27. So in this case, P also went down. So it started at 90 and it goes down to 27. So all the answers are not 27 though. Okay, let's try one more and then we'll maybe pause for the last video. If m varies directly as p squared, p to the second power, and m is 20 when p is 2, find m when p is 5. Okay, so this one's a little different because it's got that exponent in there. So we do have to be careful how we set it up. Now, varies directly still means it's a proportion. So we still should have that kind of feel to it. But m is 20 and p is 2. So if we put 20 on top, do we just put the 2 on the bottom? That's it. That really doesn't address the initial statement that m varies directly as p squared. So how we fix that is we just put an exponent of 2 on the 2. So they didn't square it when they gave it to us, but we do have to square it when we put it into our formula, if you will. So that's what the left side is going to look like. So now what should the right side look like? So find m when p is 5. So we don't know m, and m was on top. 5 should be on the bottom, but yeah, we got to square that one too. And now we have our formula that accurately represents the statement. So now we can square these. We can probably do that in our head, right? So we know 2 to the second power is 4, 5 to the second power is 25. So let's just kind of cut to the chase here. So we have 4 times m equals 20 times 25 is 500. So now let's divide by 4, and m is equal to 125. So let's see what happened. P got bigger, and so m should also get bigger, and it got a lot bigger because of that exponent, though. So it still does follow the same idea. All right, let's try one more that's more wordy, and we'll see how this one works. The interest on an investment varies directly as the rate of interest. If the interest is $48 when the rate is 5%, find the interest when the rate is 4.2%. So again, varies directly. So that automatically means we can use a proportion. Now, as far as our variables, we can make those up any way we want. So what are we comparing? We're comparing the interest on an investment and the rate of interest. So the interest and the rate. So let's use I and R. So we got I is 48 when R is 5%. What's I when R is 4.2%? So the interest rate is going down, so we would expect that the interest will go down as well. So let's see. Now what's nice about doing these types of setups is that generally you can almost steal it and put it right into a proportion. So in this case, if I put the 48 over 5 and the I over 4.2, now the question you're probably saying is, well, wait a minute, you forgot the percents. Well, because there's a percent on both sides, we could move the decimal point 2 places to the left here and 2 places to the left over here, and it doesn't really change anything. So if you leave them off or if you move them both, you're still going to get the same answer either way. So let's just leave them off, just so that way we don't have these yucky decimals. I mean, we got this one, but oh well. All right, so let's see what this gives us. 5i equals 48 times 4.2. Well, I don't want to make a mistake, so let's see what the calculator says. 201.6. And now if we divide by 5, we get $40.32. So it does go down, which is what we expected. So we're probably fine. So that's good. All right, so we'll stop the video here, and then we'll take a look at the last piece, which is inverse variation. And the setup is a little different, but it's very, very similar. So we'll see that in just a sec.